for this class, which is a version control system that is what we call decentralized. So what does that mean for a version control system to be decentralized? The idea of Git is to make it possible for you or any of your colleagues or anyone to be able to take a code base and attach specific names to specific versions of that code base so that you can switch back and forth between different versions and you can essentially save your work in different states throughout. This way, you have the opportunity, for example, when you're using Git, to commit all of the work that you have so far when you want to launch an experiment or something. And then you want to do an experiment, you're not exactly sure if it's going to work, but you want to give it a try. So you give it a try, and if it works, then you can make another commit, and now you've saved off that work. Or if it doesn't work, then you can roll all of that back to your previous commit, and you haven't broken anything that you have to undo or anything like that. Good commit hygiene can really save you in terms of efficiency as a software engineer. Poor commit hygiene you can end up really regretting if you need to go back and undo a bunch of stuff manually, particularly if it's complicated. So we'll talk a little bit about some of the commands that you may have seen before. I know that folks have a little bit of experience with Git, at least based on having pulled down and cloned down from the GitHub, the beverage app, and as well for pushing up your homework assignments. So you've done a little bit of work with Git so far. Let's talk a little bit about the commands that we already know. So I'm interested to know these commands. I suspect that you've used these before. You can type in the chat and let me know. Are these commands familiar to you? So these commands are git add. This is what we use to add files when we're making a commit. Git commit, which is how we add a commit message and then save off our changes. Then we have git push, which generally takes the changes that we've saved locally on our machine and pushes them up to a remote like GitHub. And then we have git pull, which is the opposite. That'll take changes that are already up on a remote, such as GitHub, and pull them down onto your local machine. This is where the decentralized version control system really shines. With something like Subversion, you have to have sort of a central master or like main version of your software that everybody's working off of. Whereas with Git, everybody can have their own version of the software running, and then you can merge those in and combine them together however you like. But suppose that you're on an airplane and you don't have access to GitHub or to the server or what have you, you can still write code locally and save it locally to your own Git branch, and then push that up later and merge it with other people's code. So that's what we get with Git. Let's talk a little bit about some of the other commands that will be useful for us in observing our Git history. I really like to use my Git history to keep track of what changes I've made to the application, what questions I've answered, and what questions I've still left unanswered. So let me show you an example of that. Let's talk about this command. Are y'all familiar with the command git log? Have you seen this before, used this before? No? New one? Excellent. So let's take a look at what that is. You can see my terminal here, and I've got this application called Angry Birds that I've CD'd into. This already has a Git repository associated with it, and I've already made several commits to this repository. If I want to see all of those commit messages in a list from most recent to least recent, I type in git log. Let me make this a little bigger so that I'm positive you can see it. There we go. So I type git log, and what I see here is a list of commit messages. This is my most recent commit. I see that there are a couple of things, a couple of attributes associated with a commit. The first one is this one up here. This is called the SHA, stands for Simple Hash Algorithm. And it represents a snapshot of exactly what the code base looked like at the time that I made this commit. This SHA is a unique identifier that allows me to access the this exact commit and therefore the exact state of the code base when this commit was made at any point for the remainder of the time that this repository exists and has the Git tracking in it. The next thing that you'll see is the author, that's me. You can see when the commit was made, today, and you can see my commit message. Update test to use current window selection syntax rather than deprecate key window syntax. We're going to talk more about commit messages in a second, but I just want to go through all of the attributes of a commit first. There's one more thing to note, which is this in parentheses up here. This is the branch. So we'll talk about what a branch is here in a second. But as you go down, you can see that the next most recent commit is below, and the next most recent commit is below, and so on and so forth. When I scroll down, this colon here indicates that there's more to see and that I've just used up my window space, so I can hit the space bar to continue to scroll down until I get to the end. When I want to escape out of this view, I can hit my escape key and then :Q. That's a command that we get from VI, which is a sort of text editor that we see it ships on the Mac, and it is a predecessor to Vim. So if you've used Vim, then you've used a lot of the VI key bindings. There's some more cool stuff that we can do with git log, and we're going to get to it a little bit later. But first, I want to go over some stuff about commits specifically. So this command that I'm showing you now, git log -1, means give me the most recent single commit. Git log -2 would give me the most recent 2 commits. Git log -3, the most recent 3 commits, and so on. So let's take a look at this again, the branch. We know what a SHA is now. It's a simple hash algorithm. It refers to a snapshot of the code base at a specific time. It's a unique identifier for our Git commit. Now let's talk about what a branch is. So have we heard of branches in Git or used branches in Git? Yes, no, maybe? It's okay if you haven't. Heard of them, haven't used, yes. Okay, cool. So what is a branch? This right here in the parentheses represents the branch that we are on right now. Now, a branch is essentially a name that we can attach to a specific commit in our history. So in this case, I'm on a branch called main, and I'm located at the head of that branch. We'll talk about what that means a little bit later. And the most recent commit on that branch is this one right here with this simple hash algorithm. Now, if I type in git branch, that's going to show me all of the branches that I have for this code base. So I see a few here. I see main, then I see example swipe action, and I see scream alert fix. These are all names that I have attached to specific commits in my history, so that if I check out to any one of these branches, the commit that it's attached to is the most recent commit for that branch. Now, if you were to run git branch in your repos right now, probably the branch that you would see is called master. That's the default name that Git gives you for your base branch. I always rename master to main. We can talk about reasons for that offline, but the way that I do that is I use git branch -m, the old name, which is master, the new name, which is main. If I run this command right now, it's not going to work because I don't have a master branch and I already have a main branch. But if my only branch were master, I could do git branch -m master main, and that would rename my branch. I can do that with any branch that I want to. So I could rename example swipe action to something else if I wanted to. I could rename scream alert fix to something else if I wanted to. These branches give me the opportunity to organize the different stages that my code were in. So for example, on Scream Alert Fix, let's check out to that branch. I'm going to do that with git checkout Scream Alert Fix. I'm going to hit enter on that. And now if I do git log, I want to see my commit messages, but I want to see them in a more compact format than the one that we were looking at before. So I'm going to add a flag here. Git log dash dash one line. This is going to show me my commit history with just one line for each commit. So now you can see it's a lot more compact. What you'll notice is that -m does mean move. So it's going to move your commits from your master branch to your main branch. Okay, so this is where we're located right now. Head is just wherever I am right now locally. So if I'm checked out to Scream Alert Fix, that's where head is right now. If I'm checked out to main, that's where head is. If I were checked out to example swipe action, that's where head would be. We'll see what it would mean for head to be somewhere other than the end of a branch here in a second. But you'll notice that the latest commit on this branch is no longer the key window one that we saw at the head of main. Instead, it says, move the Scream Alert to the detail page. This is a separate set of changes in my repo. And if I were to check out to one of these commits, that would represent a different version of the code than the one that I have at the very end of my main branch right now. So we've talked about checking out branches and using branches to attach to different versions of our code at different times. We can also attach to specific commits. So I'm going to show you now how to check out a specific commit. Suppose that I'm on CBF 76 AC or whatever, and I run into a bug. And I'm not sure exactly when this bug was introduced into the code base, but I want to see if I can go back and find it. We're going to talk about a sophisticated way to do this in a future lecture, but for now I'm going to say, I want to go back to that commit and I want to see if it was happening right there. So what I'm going to do is I'm going to copy that SHA with Command C, and I'm going to say git checkout that SHA. I'm going to clear my history with the exception of that command. Git checkout this SHA. So now it says checking out 7344A1. Then it gives me a message. You are in detached head state. You can look around, make experimental changes and commit them, and then discard any commits you make in this state without impacting any branches by performing another checkout. What this means is that head, where I am located, is no longer at the final commit that any given branch is attached to. We're now somewhere down the list in our Scream Alert Fix branch. We're not at the very end of our Scream Alert Fix branch. And so, if we want to make changes and save them here at this point, then we need to create a new branch here. So here we could do that by making a new branch with this command, git checkout -b. And suppose we name this branch looking for bug. So now it says switch to a new branch looking for bug. And if I do git log one line, then my most recent commit is going to be that 73 one that we checked out to. Now watch this. If I go back, git branch, if I go to git checkout Scream Alert Fix, and I do git log one line, you'll notice now that you see two branches represented in our history. Here at Scream Alert Fix is where head is located because I moved by checking out to Scream Alert Fix. You're also going to see, though, the name of the branch that we just made because we attached this name to this SHA. Under the hood, every Git commit knows 4 things. It knows its SHA, it knows its author, it knows its message, and it knows the commit that it came after. So it works essentially like a linked list. And so this commit knows this one came before me, and this commit knows this one came before me. It's referred to as the parent inside of the Git directory itself. That allows us to create kind of a tree structure where every commit knows where it came from. And even if we have a bunch of different versions of the software, everything can trace back how it gets to that base branch. What questions do we have so far? All good? Crystal clear on Git? Maybe. Let's look at some more Git pyrotechnics, and then we'll stop for questions again. So we know what a SHA is. We know what a branch is. By knowing what a SHA is and a branch is, you're already ahead of a lot of people who are using Git in their professional careers right now. Ultimately, something, my hopest of hopes is that at some point, something that you learn in this class allows you to like save another developer who gets themselves into a Git tangle. And of course, be able to save yourself if you find yourself in some kind of a version tangle as well. Now let's talk about committing new changes to our application. So right now, we know that we are on the Scream Alert Fix branch. And if I log my last 3 commits with just 1 line associated with each of them, we can see that they are these 3. Suppose now that I want to make some additional change. Suppose I want to make a file called new file. And I want to commit this change. Here, I'm going to use a command called git status. Have we used git status before? Are folks familiar with git status? Or is this new? Yes? Yes? Cool. So you know then that git status tells me which files are tracked and have been changed and which files are untracked. And you also know that if I do git add dot, that's going to add tracking for all of the files that currently have changes in them or are new. So that if I run git status again, now the file is in green because it indicates that when I do git commit, that file is going to be committed. Worth noting here that if I were to, let's say that I wanted to put something into new file. So now I've changed that file and I run git status again, you see that I have already staged. That's what it means when we add something for a commit to be made into. The fact that I added this file is staged. The fact that I changed this file is not staged. So if I were to make a commit right now, that file would be added to my commit, but it would be empty. The changes that I made to this file have not yet been staged. And that's what I do when I do git add. I can also add an individual file like this. So if I had several files that had been changed and I only wanted to commit some of them, I could add specific paths like this. As a matter of fact, you can also add specific chunks of code. You can do git add -p. And this is going to allow me to go through and say for each individual chunk of code, do I want to commit it or not? So it's asking me if I want to stage this hunk, and I have some options, yes, no. There are a bunch of fancy options. We're just going to go over yes and no. Let's say yes, I want to stage it. Those are all of the hunks, so we're done. And when I do git status, now all of my changes to that file have been staged. There's one more thing worth noting, and I will add another file to demonstrate it. Touch another new file.txt. So now if I do git status in my repo, I see that I have these stage changes and then these untracked files as well. Suppose that I had made changes. Suppose that I also do this, echo I'm going to add this line to new file. And so now when I run git status, I have a couple things going on here. I have changes that are staged. That's going to be hello in my new file. Changes that are not staged, that's going to be goodbye added to my new file. And an untracked file that has not been added to Git yet. If I do git add dot right here, new file and another new file are both going to be fully staged so that if I commit, all my changes go in. If I only want to commit my modifications to my tracked file, new file, and I don't want to commit another new file, which I haven't started tracking yet, I can do that with git add -u. And now you see that in green, all of the changes to new file are about to get committed, but this file, another new file, which I have not added yet, will not be tracked. So this can be useful if you only want to add files that you've changed, but you've got like some stuff floating around in new files and you're not quite sure what you want to do with it yet. That's useful. I'm going to go ahead and say git add dot now, and that's going to add all of my files. So now everything is in green. So that's how we can use git status, and that's how we can differentially commit different things, stage and unstage different things for committing. So now all my stuff is staged. When I commit, all this stuff is going to be saved. And the way that I would commit it is with git commit -m for message. And then I'm going to put some message in here. So let's talk about commit messages for a second. Have folks heard advice on how a commit message should be done? Folks have any advice on how to make a commit message? There's some common advice that kind of goes around. I'm interested to hear if you've heard it. No? Okay. Should include the Mira ID. Yeah, so some places, if you're working with Jira, right, or Trello or Tracker or whatever your organization is using, sometimes they have stories or tickets or tasks, and there's an ID associated with those tasks, and you put the ID associated with the task into the commit where you complete the task. That's common. Another common piece of advice for commit messages is that they should be short. Typically, the numbers that you'll hear thrown around are something like 50 to 80 characters. I want to talk about why that is because it's a little bit of an outdated recommendation. So the reason that commit messages are said to be most legible at the 50 to 80 character range doesn't have anything to do with the actual technology. It has to do with the fact that when Git was becoming popularized as our version control system, the vast majority of the terminals that it was being used on were 50 to 80 characters in width. That's not true anymore because we have much bigger and wider screens and much higher resolutions. If it makes sense to make a title message for our Git commit that is under 50 to 80 characters, it is because GitHub and GitLab and Bitbucket have browser user interfaces that cut off the commit message after 50 characters. But it's a limitation of the tools that we are using as Git clients. It does not have anything to do with Git itself. And I want to make a point of that because I think it's really important to know that you can use commit messages as a way to store critical information about the history of your project that other developers might not necessarily be able to glean by looking at the code itself. So let me show you an example of this. I'm in Angry Birds here, and let me do when was Git invented? So Git's actually not that old. Git was popularized in the 2000s, I think like 2007 or something like that. That having been said, Git became very widely used very fast. That wasn't necessarily because of the genius of Git as a decentralized system. It certainly was not because of the ease of use of Git. Git is much easier to use now than it was in 2007, believe it or not. And even now, you see the commands are kind of esoteric and they're not necessarily particularly intuitive. The reason that it became popularized so fast was that The original creator of Git, this guy, Linus Torvalds, was in charge at the time of the Linux kernel, and he forced Linux kernel developers to use Git on the Linux kernel. Because the Linux kernel was so important in computing at the time, Git became rapidly popularized that way. But it wasn't because people particularly wanted to use Git at first, or because Git captured people's hearts at first. It was because there was this influence of a massive project that caused the change to become so ubiquitous within the programming community. We see a similar thing with a lot of the conventions that we think of as ubiquitous in the programming community. We're going to get to this later, but we're going to talk about different ways that you can talk to a server over HTTP. And there's one particular way that it's done, REST. If you haven't heard of it, that's totally fine, but it's extremely popular and a lot of people think of it as the only/best way to interact with a server. The reason that it is so widely popular doesn't have as much to do with its merits as it has to do with the fact that Rails, web framework for Ruby, chose that as their default convention at a time when Rails was an extremely fast way to get a web app up and was growing in popularity extremely quickly. And so it was just what people learned and what people knew. And developers tend to gravitate towards what they already know, particularly when they're under deadlines. And so a lot of times the things that we use as programmers are extremely popular, and it's not because they were the best tool for the job at any given point. It's because they happen to be there or happen to be chosen by the right project at the right time and the right people, or folks were forced to use it. There's all these like social dynamics that go into it, which I think is super interesting and adds to the drama of being a programmer. If you're into reality TV, you'll totally love it. But it's good to know those things because people will sometimes tell you like, this is the way it is because this tool is better, or this is the way that it has to be. And I want you to have an instinct for questioning that. Just because people say it's true doesn't mean that it's right. And there's value a lot of times in going to the source code to determine how things really work, because a lot of times it's really easy in programming for unfounded assumptions to get really popular, and then everyone makes an inaccurate assumption about the way that something works, and no one's ever really questioned why. Does that make sense so far? Awesome. I'll get off my soapbox now and keep talking about Git. All right. So we talked about commit messages. I like to make my commit messages really descriptive when it's going to help other developers. I work in teams a lot, and you'll work in teams a lot. So it's really valuable to know ways that you can make your code maintainable and legible to other developers. Let's take a look at some commit messages here again. And I'll see if I can pick one out for you. So here's a good one. So you see this commit 9F0, some stuff that I made on April 1st. I say here, use a table view as the organizing element for a detail screen. Oh, nope, we're not going to use this one. Let's see. Let's use. Let's look at a different repo. Let's look at IBG posts. Or I have an even better one that we can use. Let's do view. All right. So let's take a look at the history of this. Oops, sorry, let me make this bigger for you. I know folks are not always working with the best screen resolutions. Cool. All right. So you'll see here that I do use a lot of short commit messages. But sometimes I'll let them get past 50 or 80 characters because I want to make it super clear what was happening, because I want other developers to be able to figure out what I was doing and why. Sometimes the code by itself doesn't make sense, and a commit message is an excellent place to store temporal information about why you made choices. Sometimes I'll use a commit message to indicate why I did something if it's not going to be intuitive, because if that code ends up getting changed later, then that reason no longer applies. I'll also put questions in here that I still have to let other developers know what information I was missing at the time that I wrote this code, so that if they have that information later, They have everything they need to be able to question the assumption that I made and determine whether it was valid or not at the time. That's how we avoid continuing to go off of a wrong assumption that I made in the past because nobody realizes what all those assumptions were. Let's take a look at some more commits here and I'll see if I can find. I might have to provide some examples after class. Cool. All right. So moving on, we talked about committing for maintainability. We talked about detached head state and attaching to a branch. Now let's take a look at the commit annotations in Xcode. So I was saying you can use commit messages to be able to communicate temporal information about the reasons that you made choices to other developers. You can see in Xcode the last commit message for a given line of code when it was last changed. And that can be useful for understanding why that line of code is the way it is. And this is the way you're going to do that. Let me open Xcode for you. This is not going to be the project to show you this on. Let's take a look at Angry Birds. So I'm going to get some code out here. Let's whip out some code. Let's look at my list view controller. I picked this file because it's pretty juicy and we'll be able to see a lot of commit messages, I hope. All right, so I've got this file. A bunch of changes have been made to it at some point in time. So I'm going to go up to Editor. And I'm going to go to Authors right here. Editor, Authors. And I'm going to click on it. That's going to open this sidebar over here, and it's going to show me for every line of code, what is the last commit that touched this line of code, and what was the message on that commit. So here we can see I made a commit that moved a Scream alert to the detail page, and that affected these lines of code. On March 28th, I wanted to include a new handler that plays a sound when a guest wants to scream at a bird. And that affected this line of code. I wrote a commit called closures and accessory views, and it affected that line of code. So now you can see that if I were to include in a commit message some information about why I made a choice, you'd be able to see that in the sidebar right next to the code that it changes. I often prefer this method of storing that kind of information over comments because comments can sometimes get out of date if people change the code and then forget to change the comment. But if you're changing the code and you commit over what was previously there, then the commit message that was sharing the information about why it was a certain way is replaced when you change it. And so I'll keep the temporal information in commit messages unless I'm pretty sure it's always going to be a certain way or is going to be a certain way for a long time. And in those cases, I'll tend to use comments in my code. Does all of that make sense so far? Yeah? Rock on. Let's see some more stuff. All right. So let's talk about searching in a file's commit history. There's one vulnerability in the way that we're looking at this commit history right now. And it has to do with renames. So let me show you another repo that I have. It is Angry Birds up here. Let's look at the branches. Perfect. Okay, so inside of my terminal, I can look at the history of a specific file similar to what we're looking at in Xcode, but suppose that I just wanted to see a history of that file from most recent to least recent, just like I look at with git log, with the exception of the fact that I only want it to be for a certain file. So this is how I would do that. I can use git log however many of these I want to see, and then a path to the file. We'll talk about these two flags in a second. So if I wanted to do git log, and we'll do one line here, a path to a specific file. So this might be that. What I'm seeing here is that I have these 5 commits, which is not that many commits for a project that's as big and as old as this Angry Birds app is. There are hidden commits here that we are not seeing, and the reason that we are not seeing them is because at some point I renamed this file from whatever it was named to bird list view controller. I'm not seeing any of the commits that were made to this file before that rename happened. This is because of the way that Git stores information. It's quote unquote doesn't care about names. And so the result is that we have to have a sort of like a bolt-on procedure to make it possible to follow a file that has been renamed. The way that we do that is with -- follow. So if I repeat the command that I made before, except right before the path, I put -- follow. You see more stuff. Previously, we had only 5 commits, and now we have 7 commits. These two, you'll notice, are not up here. And the reason for that is that these 2 commits were made prior to me renaming this file. It had a name at a prior time, but I was making changes still in this same file. And by using -- follow, I'm able to see the entire commit history of this specific file, including the renames. There is one more flag I want to show you, which is -p. So this allows you to look at the specific changes that were made to this file over time. I don't really like to look at this in the terminal because it's just long and it's a little bit difficult to see. There are other ways to do this. So we're going to talk about ways to look at the differences between 2 versions of a file in Xcode later. And there are other tools that you can use besides your development environment. There's one called GitX, which is really popular for this. All that those Git like visualization tools are showing you is exactly this in a nicer format. So you do have that option if that's the view that you would like. It's not the view that I like, but it's something that's available to you. All right. So finally, I want to talk just a little bit about remotes, because remotes are what you are going to be using to submit homework in this class. And your homework for this week requires you to understand something about remotes that regular old push and pull doesn't. So this will be relevant to your homework. Now, when you make a new repo on GitHub, they give you a set of commands and they tell you to run them on your command line, right? And these are 2 of them. So what do these commands mean? It's easy to copy and paste them from GitHub. And for the most part, I trust GitHub, but I do want to mention that in general, it's not a good idea to copy and paste commands from the internet into your terminal and just run them if you don't know what they do. Because the terminal is a place where you can do stuff that harms your computer, like scarily easily. And so it's really important if you're going to be running commands in the terminal that you know exactly what those commands do. So these 2 commands you run when you're making repos with GitHub, let's talk about what they mean. This says git remote add origin. So what these 2 commands are doing is they link up a repo locally on our machine to a location on GitHub, and then they push all of our code, copy all of our code to GitHub from the spot on our local machine. So we run these 2 commands in the directory of the repository that we want to push up to GitHub. The first thing we do is git remote add origin. A remote is a place outside of this local machine where we are keeping a copy of our repository. In the case of GitHub, it's GitHub, but it can also be stuff like a Docker Hub, or you can do it on GitLab, you can do it on Bitbucket, you can push to Heroku, which is a deployment strategy. You can do it with Google Cloud Platform, a lot of AWS stuff. You can do it with Azure from Microsoft. So there are a number of different remotes that you might want. And the Get Remote API is the one that you're going to be using to push to all of those. You're saying Get Remote Add. I want to add a link between my local repository and some remote location. That's Get Remote Add. Origin. I want to name this link Origin. So the link between my local repository and the one on GitHub is going to be called Origin by default. I can name it whatever I want, but in this case, that's what we're doing. Get remote add a link between me and this remote. Origin, call it Origin. And the location of that remote is this. It's this URL on GitHub. Get remote add Origin, some URL, add a link between my repo and this URL and call it Origin. Does that make sense? Yes? Awesome. So then we have git push -u origin master. This is the final commit that GitHub asks you to run in order to push your code to master. So, or rather to push your code to the origin. So there's an assumption baked into this code that I want you to be aware of because it's not going to work if you have renamed your base branch from master to main. GitHub assumes that the base branch, let me revise that. Until about a week ago, GitHub assumed that the base branch of any Git repository was called master. Reason being that that is the default on Git. If you rename your branch from master to main, then this command becomes git push -u origin main. Because this is what this command is doing. Git push, send my local code somewhere, -u to an upstream location, as in if there's changes at that location, then I want you to force me to pull those down before I push this up. Git push -u upstream. Origin to the origin remote, which I created in the previous command. Git push -u origin, push upstream to my GitHub remote, the branch called master. So if you've renamed your base branch from master to main, this command becomes git push -u origin main. So that becomes relevant because we're going to be pushing multiple branches in our homework. And this is what that's going to look like. Let me show you a little bit more about remotes. Let me CD out of here. And then actually, let's go back over to our. So we're in Angry Birds here. Yep. So in the homework, you're going to be creating your own branch. All right. So suppose that I wanted to go git checkout looking for bug. Suppose I want to collaborate with somebody on this thing where I'm looking for the bug, right? And I want somebody to be able to pull this down from GitHub and help me look for this bug. So I want to push this specific branch, this version of the code, so that somebody else could look at it. Now we've already seen the command git branch, which allows me to look at my branches. We can also look at our remotes with git remote -v. So I don't have a remote for this right now. And if I wanted one, I would need to run this command, git remote add origin, whatever, whatever, whatever. So let's take a look at another repo here. Let's look at Angry Birds. So I have all these branches, right? Let's say that I want to make a new file here. I want to check it out to a new branch. We've done this, git checkout -b new branch. I want to check its status. I want to add my file. And I check my status again. It's added. Git commit. We'll use example commit message. And then I'll explain this is an example for class of pushing a branch to a remote. So now I have my commit. When I do git log -1, I can see my commit. That explains why this commit is there. And so now, if I do git remote -v in here, I have a remote. This is linked up to GitHub already. Now I could have a lot of remotes in here. I have Origin, this one goes to GitHub. I could have one called Heroku or to anywhere that I was deploying. I could have one called Docker that pushes this to Docker Hub. You can have as many remotes as you want. Most of our projects will have just the one. You get this remote when you run this command, git remote add origin, etc., etc. So now I want to push my branch. What branch am I on right now? I'm on new branch. So if I do git push right now, it's not going to work yet. The reason is that my remote doesn't know anything about this branch yet. The current branch, new branch, has no upstream branch. We have an upstream remote called origin, but it's never seen this new branch thing before. So we say git push -- set upstream origin new branch, like this. And then when I hit enter, it goes up. Now on GitHub, I would be able to access that new branch. Let's take a look at that. Let's go. In fact, let's do it this way. Let's do git remote and get a hold of this. Now, GitHub's going to try to be helpful when I go here, I think. It says, new branch has recent pushes less than a minute ago. It's going to ask me if I want to open a pull request. And if I click on that, this is going to automatically create what's called a pull request for me. In the GitHub UI, we're going to be able to view our pull requests here in the pull requests tab. I see my new branch pull request where I can view all of my commits, and I can ask people to review my commits. Congratulations, Lauren. And at this point, she could leave comments on it and we could start a discussion about this code. Should it be changed this way? I don't like the way you did that, this, that, and the other. Developers can have a conversation in a pull request about the way that code should be changed. Ultimately, when everybody's happy with it, you can hit the merge button, and that's going to take all of this code and it's going to merge it into your main branch, which is the one that